Hi everyone, my name is Kilanko Oluwaseun. I'm a lecturer in the Department of Mechanical Engineering, Covenant University, Nigeria. I'm a CSWA Associate, CSWP Mechanical Design, CSWP Advanced Drawing Tools, and also I'm an Associate in Additive Manufacturing. I've been teaching this SolidWorks since 2015 in my institution, Covenant University, when we subscribe as an institution to be using the software to train our students. I've trained so many students who have also backed their CSWA. If you go to Nigerian portal in SolidWorks, you see that most of those who have CSWA, they are from Covenant University. And it is because the software is a very great software for design, and students, they really love it, they like it, and they key into using the software for most of their designs. I believe that this software is just gaining ground in Nigeria. I believe that with a little more effort, the software will spread around, and it will become what the industries are also using for their design. So today I come with a little presentation to show a little of my ideas on SolidWorks, on how to generate chain drive in SolidWorks. So I believe that the little idea I have to share will help somebody, especially those who are just coming up, that want to know how to use SolidWorks to generate chain drive to drive their machines. So sit right back. I wish you best of luck. Hi everybody, I'm Kilanko Oluwaseun from Nigeria. I'm here to present to you how to generate chain drive for your machine. I have here a machine called sugarcane juice extractor. It's a machine that the local farmers use to extract the liquid from sugarcane in the farm. So the machine is a very simple machine with some mechanical components. It is driven with chain drives. So this is the machine. So here we have the chain drive. This is the control panel. Let me remove the frame. So this is the chain drive that is used to drive the rollers. On this side we have the extracting rollers. These two rollers are extracting rollers, while this one is the crushing roller. So this is the feed upper. The sugarcane comes through this channel and it comes between these rollers. So this one crushes it and this one extracts the juice. So the sugarcane passes through this place to the outlet, while the juice drop on this juice conveyor plates and is collected outside here. So we have the roller shaft with bearings. We have this bearing plate 1, bearing plate 2. So we have 3 roller shafts of the same diameter, 15 mm. So they are connected to sprockets, these 3 sprockets. So we have one sprocket at the shaft of the electric motor, which drives the rollers. So what I really want to do is to show you how to generate this chain drive. So what I have here, I'm going to suppress all this and show you how to go about it. It's a very simple way when you're using SolidWorks to do that. So let me suppress the 4 sprockets, these 3 sprockets, and also the one on the motor. Then I will also suppress these chain links so that I can show you how to go about it. So let's see how to get that done. So let me remove these are the sprockets. Then we have the inner chain link and the outer chain link. Then also we have the belt drive and the chain pattern. So I want to suppress all of these so that I can show you how to go about it. So now when you have a system like this, okay, let me remove the motor sprockets. So when you have your shafts, I have the 3 shafts here with the key on the keyways, and also the electric motor too has the key on the shafts. So I will show you how to use SolidWorks to generate the sprockets and also to bring it here. Then I'll also show you how to develop your chain links and how to bring it to the assembly and use the SolidWorks tool to put them together. So let's start. So I'm going to generate the sprocket from the SolidWorks library. So I go to Toolbox. So using the ANSI inches standard, so I come to the power transmission, then the chain and sprocket. So here I'm using the detachable link sprocket. So right click and create parts. So it opens a sprocket for you, so you can configure the component here. So for the electric motor sprockets, I'm using the sprockets with 6 number of teeth. Then I'll be using the hub diameter of 1.2. Then the shaft diameter of the sprocket is 9/16, which is almost 14 millimeter diameter, because the diameter of the electric motor is 14. So I'll be using this. So the sprocket has the keyway and it has up on both sides. So I'll be using this sprocket for the electric motor. So let me accept that. So I'll save this. Save. So let me save it inside my folder. Okay, sprockets. This for the electric motor. So the second shaft I would like to generate is for the roller shafts. So using the same type of sprockets. So this one I'll be using the one with 9 teeth. Number of teeth is 9. Then the hub diameter will be 1.65. Then the diameter will be 1. Let's see. So 1/316, which is almost approximately 15 millimeter diameter. So that's the. So I'll be using this. It has hub on both sides. So this is what I will use on the 3 roller shafts. So let me save it into my folder. Save. Okay. So this for the shafts. So having this, I can come to the assembly environment, then bring in all those shafts here, insert components. So this is the one for the shafts. So create one. So since I'll be using 3 of these on these 3 shafts, just press Ctrl key down and click and drag to create a copy. Then to press Ctrl key down and click and drag to create another copy. So those 3 will be fixed on this roller shaft. Then the other shafts for the electric motor, so the one with 6 teeth. So this is for the electric motor. So you can then use your mate tool to put them together. So for this one, let me mate the sprocket on the roller shaft first. So starting with this, so use a concentric mate to put this sprocket on these shafts. So that's concentric. Then you can now use parallel mates to the flat surface of the key. So mating the flat surface of the key, so which is this. So using mate this flat surface and this. So you use parallel mates for the 2 of them. So parallel, so anti-align, yeah, so yeah, that's okay. Then use a coincident constraint to make this top face with this. So but the shaft is going to protrude out a bit with a dimension of 5.95. So I'll use distance mate type 5.95 millimeters. So it should be flipped to the other side like this. So So that's how this sprocket will fit here. Okay, so you can see that this is working. So I'll fit the sprocket to the other two shafts the same way. So use concentric mates to make this sprocket to these shafts. Yeah. So doing it the same way, making the flat surface of the key. So the flat surface, and also on the key. So using parallel, so let's see, yeah, it's now aligned, so we can accept that. Then using the coincident constraint of these two faces, so but we want it to come out so a bit using 5.95 millimeters. You have to flip. Let's see. Okay, so yeah, that's okay. We have the second shaft is in place now. So the third one the same way. Let's see. So using concentric mate again, to mate the cylindrical part of the sprocket and the shafts. Concentric, then the flat surface of the key. Yeah. This flat surface, and also this flat surface there. So let's use anti-align. Okay, so then using we're going to use this distance mates between these two faces. We have a distance of 5.95 millimeters. So we flip to the inside here. So we have our sprockets on the shafts. So each one of them is turning. So it's turning the roller, the crushing roller and the extracting roller. So let's fit the one on the electric motor. Let me get this out of the way. So the electric motor using the same mates. So concentric mates. Yeah. So then the flat surface of the key. So this is our line. Then using the distance mates. So for this one, we're using distance mates of 5.0 millimeters. Should be on the inside like that. Yeah. So I have the four sprockets in place. Then I have this plane which I've created here, which I'm going to use for the belt, this plane. So the four sprockets are aligned on the same plane, this plane. Look at it. They all align on the same plane so that I can be able to use this when I want to generate the belt, which I'm going to use to pattern the chain. So they are all aligned on that plane. So now the next thing now is the link that we are going to use to generate the chain on these sprockets. So we will have to create our link, both the inner link and the outer link. So let's see how to do that. So I open a new part. So save it to be, let me put it here. So I'll call this one inner link. So start a new sketch, put it on the front plane. So center line from the origin. So draw a line, a circle. Dimension of this one. Dimension there is 14. The diameter is 14. The diameter of this one is 11. And the diameter of this one is 7. So then the distance here is 12.18. Some of these dimensions were calculated from the sprockets, the profile of the sprockets. So this fully defined sketch. Then mirror this about this line. Yeah. So then 3-point arc. So this arc is tangent to this circle. So add tangent relation. Then this arc and this circle. Tangent relation. Then the radius for the arc is 20. So then mirror this about the this center line. Yeah, like that. So that's our sketch. So this we can now select contour tool, so then extrude by 2 millimeters. 2 millimeters. Yeah. So then extrude, select contour tool, so extruding so we're going to extrude that to give us 9. Let's see. That's 9 plus 2, 11. So okay, this is the inner link. We are extruding this is the roller diameter. That should be so that's by 11. The distance we have here is 9, which is the face width of the sprocket. So then to copy this on the other side, you need to mirror or create a plane, mid plane between this and this face. So this mirror plane, we use it to now mirror the boss extrude 1 on the other side. So something is wrong there. So let's see what's the distance depth should be. we have distance of 9. Okay. So, but our chain drive is supposed to, let's select contour 2, this, and also this, extrude cuts, then it should be the other way, through all. Yeah, so this is our inner link. Then we need to fillets on this side, fillet of 2 mm, so okay, so something is wrong there. Let's see. The fillets, let's see, something is wrong there. The thickness of this is supposed to be okay, it's supposed to be fillet of 0.5. The fillet is too much, so it's fillet of 0.5 millimeter. Yeah. Yes. So this is our inner link, and we have the mid plane, which we are going to use for the alignment when we are positioning it on the belts, when we are generating the chain drive. So the second one, which is the outer link, chain link, so create new sketch, center line, so circle, another circle, another circle. So this circle is 7, that's 4. That's 14 diameter. This one is 11 diameter, while this is 7 mm diameter. So this is 12.18. So the same thing, we mirror this on the other side, mirror entity, about the eye. So then 3-point arc, so this arc should be tangent to this arc, tangent. This arc should be tangent to this circle. The two of them must be tangents. Let's see. Tangents. Okay. So the radius there between there is 20. So we mirror this line about this to get that. So we have a fully defined sketch. So we can now extrude, use contour select tool, so we have 2 millimeter. Then here we need to extrude. So using the contour select tool again on this circle. So extrude. So should be on one side. So it will be 18.1, then direction 2 to be 1. Then creating a plane, mid plane, between this and this. That's the mid plane. So we mirror the boss extrude 1. On the other side. Yeah, like this. So then this end, let's pattern this. Our right plane. So using mirror, boss extrude, yes. So with this we can fillet, using 0.2 millimeter. Like that. Then we can also dress up this, put in a sketch, center line, center line, so using 3 arc, using small dimension. The dimension here is 1.5 and using the vertical constraint for this to constrain their hand to go the same way. So we extrude cuts. So extrude cuts, revolve cuts, sorry. This is the axis. So revolve cuts that. So we dress in that. So we can mirror that on the other side using this plane for mirror. Then we can also mirror the two using the right plane. So we can mirror the two to the front. So then fillets using 0.2. Fillets. So 0.2. So with this we conclude on our outer link. So we can go back to the assembly and bring in the two links we have created. So the inner link, the assembly. Okay, so we insert components, inner link, then place one, then the outer link, insert component, outer link. So the next thing now is to generate the belt. So we use the assembly feature belt/chain. So when you click that, then it prompts you to select the members of the belt. So you select the sprockets at their pitch circle. Let me start from the motor. Yes, so this is how our belt is going to fit in. So you select engage so that the belt will engage all the sprockets together. So you can, the belt location. So we're going to use the plane that I created, this plane that align all the sprockets together. So you can see, so that our belt can be at the middle of all the sprockets. So select plane 1, you can see it aligns it. So with this, we have the belts which we can now use to pattern the chain. So with this now, we can come to linear component pattern, chain component pattern. So you can select this. So choose the third one, connected linkage. So chain parts, it prompts you to select the chain part. You select the belt that we have generated as a part. Let's see. Use selection manager. Okay, let's go back. After this one has been generated, let's see. Oh, there's an error there. Let's do it over again. So belt and chain. So this is where it's supposed to be. The engage belts. Then for the plane, supposed to align on this plane. So it's giving an issue there. Which we may have to resolve. We may have to disengage the belts because it's generating error here. So let's delete and reassign. So assembly feature belt chain. So this is how we want our belts to look like. It should be on the plane. Then disengage the belts. The mates applied to the sprockets are the ones that are giving error. I think it's okay now. So we can now begin to use the inner link and the outer link to generate our chain on this belt drive. So what you use to do that is the pattern component, that's chain component pattern. So you select the third one, which is connected linkage. So we need to select the belt, which is this. So select the sketch of the belt drive. Then the first group, you can select any one of the two chain links. So this is the first group. Then the first part link is this roller diameter. The second one is the second roller diameter. Then the part alignment. So we use the mid plane we use for the link. We created mid plane for it, which is this mid plane. So that's the one we use. Let's fill the parts. Then the second group is the outer link, which is this. Then you select the roller diameter, then the second roller diameter. Then we also select the mid plane for the outer link. This mid plane that we created. So it will use that to generate the chain. So that's how this was done. And you can see, okay, the SOLIDWORKS could not complete because the distance it remains for it to join the last chain is not up to the required distance. That's why it leaves it like this. And this can be resolved by maybe adjusting the position of the sprocket, or when you ordered for the chain, you also order for extra links which you can use to complete it. So this is just the way that you can use to generate, or we can ask the SOLIDWORKS to complete it anyway. You can edit feature, then instead of, let's see, the chain pattern, so instead of fill the path, we can ask the SOLIDWORKS to add one more chain to complete the loop so that it will look complete on our machine. So this is just one of the ways by which you can generate this mechanism, the chain drive for your machine. So I hope the knowledge shared in this will be able to help somebody out there. I want to believe this is insightful, and we help somebody to be able to generate chain drive for their machine. I wish you good luck. Thank you for listening to my presentation. I hope you have been able to gain one or more things from the generation of chain drives. I wish you best of luck as we sit down to listen to other presenters that have a lot to present to us on SOLIDWORKS. Bye-bye.